Our first speaker today is Phil Cockfield. Phil is a co-founder of Respondly, which is built with Meteor. Companies including Stripe, Pocket, and Tweetbot use Respondly to manage customer email and Twitter conversations as a team. Phil is both a designer and a full-stack engineer, and he has a long-held interest in architectural strategies to modularize and test UI in an isolated fashion. Phil is currently working on a new way to construct UI, blending manual manipulation with automated unit tests. Please welcome Phil.
G'day. Hello, everyone. Today, I'm going to be talking mostly around UI, and I'm going to start with unpacking Respondly and giving a feel for what we've done in Respondly and the surface area of the Respondly UI. But then I want to move it into talking about modular design, how we can start breaking our UIs, particularly as they get extremely large, into modular patterns, which leads into the UI harness. So with that, let's look at Respondly as it was introduced. Respondly is a tool to help folks respond on social media as a team. Kind of the value proposition here, imagine you have your own Twitter account and how difficult that can be just on your own, managing that, staying on top of it. But then imagine if you had a friend or a group of friends and you all had to talk with a consistent voice through that Twitter account. It gets really complex. So this is where Respondly's value proposition comes in, which is to provide a whole bunch of real-time coordination tools so that teams can operate in a coordinated fashion as a single unit coming through social media, starting with Twitter. So to do that, and simulate, kind of get a feel for what this is all about, I've created a fake organization here called Fake Meteor. And we will all be team members of Fake Meteor, and we'll be managing Fake Meteor's at Fake Meteor Twitter account through Respondly. So I'll jump over to the browser and bring up Fake Meteor. It's loading now, and we've got a bunch of tweets coming in. If I select a tweet, we can see that we get a parent-child relationship here. We can see the conversation flow. I can move through it. And I'm going to have a look at the team. If I open this panel here, we get the entire team. Maybe I'll add another team member. Let's jump through Colin Durant. And if any of these people want to log in, we can see the real-timeness of this as the users come in and we're all moving around and collaborating. Cool. So this person's just come in. It's Katie. I can see Katie's online. I can see she's online. I can also see she's active. It's got a little green dot. If she was inactive for 30 seconds, that would disappear. If she was inactive for longer, that would fade back. But I would still know that she's online. She probably has a tab open and walked away from it. Here we've got collision control, or at least collision prevention coming on with me and, who's this? Emily Stark is looking at the same tweet here. So we know that we're not going to walk over each other. I'm either going to not respond to that tweet. What I might do is say, hey Emily, I want to take this one. And so we can have an internal private conversation on there. What I also might do is say, let's follow up on this one, say next week, pass that into a date. I'll add me and let's put Emily on it as well. And that will now follow up in 7 days. I could archive that, get it out of the stream. Also, another feature of this is that it's entirely drivable from the keyboard. So I've just hit the little icon down here. I'll bring up the key hints, including a key hint for key hints. So at any point, we can hit question mark, and we can see what can I do at this point. This is often a problem with key enabling applications. To go somewhere else, learn all the key hints, and then come back and have abstract descriptions of what, where and what that feature relates to. So yeah, so that's that. And I didn't want to spend too much time on Respondly because I wanted to get back into looking at UI, and we'll move forward and unpack some of the UI here and look at modularity. So by way of analogy, this is how I would like to think UI code is beautifully tended Zen garden. And this is probably true, and certainly it is true with all code, but it feels more true with UI code. The moment you turn your back, this is what it does on you, right? Like it just turns into this jungle, tangled mess. And so what do we have at our disposal to bring it back into this beautifully pristine, curated fashion? And there's three kind of moves here. It's all around encapsulation, breaking problems down and encapsulating it as much as possible, which enables reuse, and then ultimately leads towards applying a nice dry, don't repeat yourself principle. Within Meteor, there's the overall organizing system for that, which is the packages. Package system's really quite beautiful in terms of how it handles bringing the client and the server-side code together and managing that, and in particular the namespacing system that it opens up. Then within that, we have this thing called a control, or a UI control, which is a thin wrapper we put around the templating system, which is mostly to do with enabling formal APIs on top of the control. There are a bunch of other helpers that we put in there, but really it's about how do we get an API that we want to publish out as a contract for other consumers of the control. So, to give you an idea of that, make that abstract idea a little more concrete, this is the follow-up controls or set of controls that we saw in Respondly. The way that breaks up into a whole bunch of controls is like this. You know, there's a user selector there. The user selector brings up a user select list, and then there's within that, the list is a set of items, which ultimately all sits inside a pop-up. And each one of those controls is responsible for doing a very isolated thing. But when we think about that, and we think about it in terms of reuse, we have this spectrum. And reuse is not free, right? So reuse is this Shangri-La. Isn't it great if we can all get to reusing everything? But where on the spectrum of hard to easy do we sit? So on this side, you'll have stuff that's like totally not reusable. You just shove it into your app where it is. You can't use it again, and that's probably about the easiest thing you can do to get going. But then it gets expensive later on because you've got to rewrite it to move forward or refactor it out. Over on this end of the spectrum, you've got stuff that's like totally, utterly reusable, but that's incredibly hard, particularly when you bring in a long tail of possible edge conditions. The classic case is a third-party control of like a data grid, right, that does every damn thing possible. Incredibly hard to write. What we see is this beautiful sweet spot in the middle, somewhere between idiosyncratic reuse and good enough reuse. So idiosyncratic reuse would be in your app. It's relevant to your value proposition of your app, but you can reuse it within that context. Over on this side is good enough reuse, where it makes sense to reuse in a generic fashion, but you're wiping off that long tail of doing every possible edge case condition. It's just good enough for you, or you and a few others in your friends of companies. So the way we factor Respondly is, in support of that, is like this. We have two repositories, the Respondly app, which is where all the idiosyncratic reuse exists, and then we have this other thing called core packages, where we have controls that are intended to be reused that have nothing to do with Respondly's specific value proposition. So if we take a look at that, here's an example of that kind of thing. We have a list of all of our internal controls. If I have a look at this one, here's the slider. It's quite an isolated control. I can manipulate it through UI, change its size, put messages on, and so forth. Other examples of that, let's have a look at, say, the overlay system. This was the thing that was bringing up the key controls. We might have an overlay system in a sequence, so we could step through things. Get rid of that, done. Through to quite sophisticated or large-scale organization structures. This is the millicolumn system that we used, where we could add multiple columns, and this is the entire app was structured within this. So I want to point out here, what we're doing is looking at this control, but then we have a bunch of buttons up there that are just ad hoc thrown in with event handlers, where I put custom code behind it to exercise and manipulate the API. And that's good. It's certainly better than not isolating a control and testing it, but it has some drawbacks, and this gets us up to where we're taking things now. which is the idea of a UI harness. It's a DSL that we're developing for rapidly building clean and reusable UI in a modular fashion. And what it does is it takes ad hoc scaffolding on this side, which has these beautiful virtues, right? Super flexible, I can do anything I want with it. I can manually manipulate it, which is the key thing as a UI developer, right, is to get it up and to poke it around and click on it and so forth. But I can also programmatically manipulate the API from the outside. On the other side, we have unit tests, which have these qualities. We can describe behavior in a formal manner, so there's a design component to it. We can assert correctness, which then means we can automate it and bring it into a CI situation, a continuous integration server. So with that, we've started with the behavior-driven development semantics as our DSL base. So anyone who has come from RSpec or RubyLang will recognize this. A describe statement will describe my thing. Within that, we have a set of suites, or sorry, within that suite, we have a set of specs. So it does something. And then within that, we expect a value to equal something. We can assert its correctness. So if I jump over and show how this works in the UI harness, this is the UI harness here on the right. And I can start, say, describing something. Let's describe Devshop. And we'll see Devshop shows up in the UI. Within that, say I'm going to describe something called Galaxy, which is a control I prepared. If I step into this, this suite, we can see galaxies there. I'll step into that. And then what I'll do is before everything, I will load a control called Galaxy. What that's now doing is getting the control up so that we can manipulate it. From there, I can start doing a bunch of assertions on it. Say this control and it has a method. It has two methods, show a meteor and hide a meteor. So I'll create some specs for that. Show the meteor, hide the meteor. Here I'll get a reference to the control, call the show meteor method, and then call the hide meteor method. These have now shown up here as runnable specs. If I run that, we get a meteor showing up. If I hide it, it disappears. So what we're doing here is achieving everything that we did prior with our ad hoc specs or our ad hoc test page, except it's in a purely formal way. We can now run these specifications through a CI server or through something like Velocity and then plug it into a CI server. And we could put assertions in here to say, when that method runs, was the meteor there? Was it present? Was it in the state that we expected it to be? Taking this a little bit further, which is where we begin to extend the BDD dynamic DSL further, is to say, and now there's a property on this control called isRed. And isRed is a Boolean method. So I can go it.boolean isRed. And now I don't even have to put any test code behind that spec. It's brought the isRed in, assumed that it's Boolean, and gives me this toggle. And so now I can set that value and change it and so forth. And with that, I have 2 minutes left, so we can go straight to questions. Sorry, could you repeat the question?
You've got extension for Booleans. Do you expect to have maybe like a text box?
Yeah. So that's the interesting place we can go to. The question was, we've got Boolean here, it.boolean. What are the other directions that we'll be taking the DSL in? Obviously, we want to add strings. We want to add the ability for radio buttons for common options where we have multi-choice options. And potentially object, putting arbitrary objects and passing those in as parameters. So that's one area of the way that we can take the DSL and reduce the friction in creating this the test junk, all the junk for manipulating it. The other thing here is to bring documentation closer to the control as well. So we'll be looking at initially putting the ability to have a markdown file next to the controls, and then have the test harness be able to load, pass and load that markdown, so we can be manipulating the control, watching it, and then reading whatever extended explanations the developer wanted to give about that control, as well as passing through the JavaScript and extracting out inline comments and having documentation within there as well.
When can we see something here?
So this will be, well, it is open source. The question is, when can we see something, in particular at the domain uiharness.com, www.uiharness. It's open source. I'm waiting for the new packaging system to drop. So when 0.9 comes out and the new package server's out, we'll be pushing all of this stuff out there.
Any other questions from the room?
Yes?
I may be like misunderstanding, but how is this better to use than like Bootstrap UI components and stuff like that?
Oh, how's the control piece better? The question is, how is this better than Bootstrap? Let me jump through to the slide that brought this up. I guess the question could be reframed like, how is Meteor better than Bootstrap, right? Or how is it different? This is a thin wrapper around the templating system, and this is how we define it, right? So all that's really doing is saying, oh, there's this template, and it's called type, or it's called, widget, it's called follow up. The first three methods there are lifecycle methods. So init is the equivalent of created. We actually started this a long time ago before Blaze came along. So we to wrap around Spark, and so it actually brought a lot more to the table because Spark wasn't doing a lot of this stuff. And then Blaze came through as a massive improvement, and a lot of stuff that we were doing with the wrapper is now just done natively in Blaze. But the concept the biggest concept here is that API and that notion of, I've got all of this internal private code that only makes sense. Like, I don't want the world to see that. I don't want a consumer to like see helper methods that make no sense and I never intended them to call it. So everything that goes on the API gets put into its own object that then gets presented out to the world. So we can get a hold of that control. Someone can work with that. And we keep all of our internal stuff away. With respect to how is it better than Bootstrap, I don't think it's like really in the same category. It certainly brings the, how would you see it?
I guess I'll rephrase the question. So I like that this kind of encapsulates the Meteor template system. But say like when we use Bootstrap, we like to customize the way it looks, the CSS of that. How do we do that with these encapsulated UI elements from UI Harness?
How do you customize the control?
Yeah,
so the UI harness makes no assumptions about what you're going to dump into it. It doesn't care. So that control, let me bring up the control that we looked at, the Galaxy control. It's in three parts. That's the JavaScript or the CoffeeScript. That's the HTML, and that's the style sheet. So the UI harness didn't know what that was until we told it, go find a control that has has a definition called Galaxy or a name called Galaxy, and then take it and render it there. And really, all it was doing was telling Blaze, take this template that you have and render it there. So there's no assumptions about what that content would be. So you'd style it any way that you wanted.
okay.
Yeah.
You could use Bootstrap, use those styles.
Absolutely. Yeah. And Respondly uses Bootstrap as its base.
We have a question from Twitter. So Yuri asks, how many people are on the Respondly team? How long did it take to develop?
Right. So Respondly's two of us. It's Tim Haynes and myself. We've been bootstrapping it to date, and we're just about to bring on more developers.
Great. And how long did it take to develop, and how did you collaborate with designers?
Okay, so 12 months we've been working on this. We started within 3 months of starting. We bought the first set of companies on. We've been officially released since April, but we've had the likes of Stripe on for 7 or 8 months, and we've been using that as a design feedback to really make sure that we're building something that can be used in production in a workhorse fashion. We're both designers, so we've been able to go a long way. Like, we're both engineers and designers, and so we can cover a lot of ground without, one, having to raise, and two, having to bring on more people to get to where we are. But now we're growing.
Any other questions from the room? All right, we're going to take a short break. Our next talk begins at 7:30, and will be Mike Rissy presenting Meteor Pad. Thank you very much, Phil.
Thank you.